All right. Exponential growth and decay worksheet. So write an exponential growth model that describes the situation. All right, so we're not solving anything, we're just setting up the problem. So in 1992, 1,219 monk parakeets were observed in the United States. For the next 11 years, 12% more parakeets were observed each year. So what are the key information? It's going to be, this is our initial amount. 11 is our, we can use variable t for time. And this is our factor, right? Our, in this case, it would be a growth factor. Okay, so we have y will be the total is equal to the initial amount, 1219. The growth, since it's growing 12%, it's going to be 0.12. But because it's growing, it's going to be 1.12, right? It has to be bigger than 1. 1.12. And then t, right? T being 11 years. So now, if I want to figure out what it would be for 11 years, we can put 11 in for t. And really, we want any number of years after 1992. It would just go in for t. So this would be the model. Our number 2, you purchase an antique table for $450. So again, this is our initial amount. It increases 6%. So this is going to be 0.06. That's our factor. And then it's just per year. So again, we'll have t as our time. So our initial investment or purchase, it's increasing. So 1.06 because it needs to be bigger than 1. And then t for however many years we have it. All right, number 3. 97 to 02. N represents millions of DVD players sold in the US. And it can be modeled by this here. N is equal to 0.42, 2.47 t, where t is the number of years since 1997. All right, what are we asked? Identify the initial amount. All right, initial amount, we'll call it IA. It's going to be 0.42 million. So about 420,000. The growth factor is going to be 2.47. So 247% technically. And t is the number of years and the annual percentage increase. Okay, so the annual percentage increase. So you got to compare this to 1. Right? This, so the percentage is going to be compared to 1, 147%. Right? 147% increase. Okay. Graph the function, find the number of DVD players sold in 2001. So really, t is equal to 4. So if we plug in t is equal to 4, we can figure this out. But we still need to graph it. So we need our x and y axis or our horizontal. So we can call this the t axis, right, for number of years. And then the vertical axis, the y axis, technically this would be our n axis, right? So you give me t, number of years since 97, and I'll give you n, the number in millions of DVD players sold in the US. So we can go by, so if we go by ones, all right, if we go by ones, this is going to look like this. So it's going to be slightly less than 1. right? Because 0.4. And then at 1, it's going to be slightly more than 1. Squared will be a little bit more than 2. 3 is going to be 6. Slightly more than 6. And then 4 is going to be slightly more than 15. So it's actually going to look like this. So when t is 4, n is going to be 15.6 million, right, DVD players. Okay, that one is kind of weird. The graphing's kind of weird, but algebraically, we're just plugging in numbers. So, okay, number 4. Each March 1998 to 03, class of 03, a website recorded the number of Y of referrals it received from internet search engines using this model here. T is the number of years since 98. Identify the initial amount. So initial amount is going to be 2,500. The growth factor, 1.50. And the increase is going to be by 50%. Okay, graph the function, state the domain and range. Find the number of referrals the website received from March 2002. Okay, so let's just figure this out first. So we got T is going to be 4. T is going to be 4, right? Number of years since 98. Well, it's 4 years. So 2500, 1.5 to the 4th power. So number of referrals would be 12,656. 0.25. You can't get partial, so we can round it up to 12657. Somehow we have to draw this. So if these are by thousands, man, it's going to get exponentially big. So 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right. So at 0, it's going to be 2,500. At 1, it's going to be a little bit more than 3. And then at 2, a little bit more than 5. 3, a little bit more than 8. And then at 4, a little bit more than 12. So it's going to look similar to this. Okay. All right. In 2000, number 5. In 2000, the average price of football ticket in Minnesota Viking game for the Minnesota Viking game was $48.28. During the next 4 years, the price increased an average of 6% each year. Write a model giving the average price P of a ticket T years after 2000. Okay, so the initial price increase 6%, so 0.06, and it's increasing, so it's bigger than 1. 1.06. T years, and P is the price of the ticket in dollars. So here's the model. And we find the year when the average price, okay, so average price is going to be P. P is equal to 60. That's what they're saying. So 60 is equal to 48.28, 1.06 T. Okay, this is interesting because the variable is in the exponent. Question is, how do we get the exponent down? So, I mean, I know the answer, but in respect to this video, you don't know how to bring that down yet. So, we have to rely on Old Faithful, just brute force. So, what's happening is we want to isolate the right side. Well, technically, we don't. What we want to do is start plugging in numbers to get this value as close as 60. So 48.28. Well, I'm in my calculator. 48.28. Now we could graph it actually and then check out the table. And where do we get close to 60? That's A way. So about 4 years if you go in the calculator, right? So all I did was fill in with 1, 2, 3 for T. 3 gets you at 57, 50, and 4 puts you at 60.9. So 4 years. So trial and error is not that bad. There is a way of bringing the variable down, which we'll cover later. So right now, 4 years, that's where we're at. Okay. All right, tell whether the function represents growth or decay. Also give the percentage. Oh, too easy. So look, this number, less than 1, decay. And how much less than 1? 25%. Right, because think about it. If this is 1, if this line represents 1, 3/4 is definitely less. And it's like, okay, well, 3/4 can be written as 0.75. Right, that's what 3/4 is, 0.75. So it's like, how far is this distance? This distance is 0.25, which as a percentage times 100 will give you 25%. Okay, 5/2. This is definitely greater than 1. So this is growth. Okay, how much bigger than 1? Well, 2/2 would be 1. So this is 3/2 bigger than 1, which is basically 1.5. So 150% growth. Okay. 4 compared to 1 is definitely bigger than 1. So this is growth. It's going to be, it's 3 bigger, right? 4 is 1 plus 3. 300%. And then last, 0.25. This is smaller than 1. So this is decay. And this is going to be 75%. Okay. Number 10. Person takes a dosage of ibuprofen. The amount of medication remaining in their bloodstream after T hours is modeled by this equation right here. Find the amount. All right. So I'll do the setup. 1.5. Actually, it's going to be, right, so this is our initial amount. and this is our T. So 200.71, 1.5 exponent. So straight to the calculator. We have 200.71, 1.5. So the amount in milligrams. So 119.65 milligrams. For B, again, our initial value is 325 milligrams. It's decreasing, or decaying rather, at 0.71 and then 3.5 hours. So 325 parentheses 0.71 exponent 3.5. We got 98.01 milligrams. And last but not least, 400.715. We have 72.17 milligrams. Okay. Number 11, new mountain bike, $200. The value decreases 25% each year. So our initial cost, $200. We're decreasing, so it's decay by 25% each year. So the decay factor is going to be 75.75 every year. So the model, initial amount, 0.75 T is equal to Y. That's the model. Okay. We want to find the value of the bike after 3 years. So T is equal to 3 is what this is saying. So 200 times 0.75 3. So Y is equal to 84.38 dollars. That's how much it's worth after 3 years. All right, using the graphing calculator to find the value of the bike. The value of the bike will be 100. When the value of the bike will be 100. Okay, so this is simply putting in the table or the graph and then looking at the table. All right, so after about 2 years, it's going to be worth 112, which is close. Right, it's close. I mean, could you narrow it down to the exact month? Yeah, probably. But the calculator only gets you, well, you have to interpret it, I guess, more precisely, but we can call it good here. This is good. All right. Number 12. The value of the car can be modeled by the equation where T is the number of years since the car was purchased. Okay. Using a graphing calculator to find when will the car be worth 10,000 or less. All right, so it's going to be after 5 years. Right, at 5 years, it's 10,339, so a few months in. Predict the value of the car 50 years after it was purchased. Is this a reasonable value? All right, so this is going to mean when T is 50. Okay, so after 50 years, the car is going to be worth $5.29. So is this reasonable? Let's go with no. It is not. It is not reasonable at all. $5 for a car. Come on. All right. Got a couple graphing ones, and then we'll call it a day. So all of these are going to be 2 to the x. That's what the parent function is going to look like, 2 to the x. So let's recall 2 to the x will look like, so I'll do the parent function once in black. More or less it's going to look like this. All right, so if it's going to +1, this is going to shift it left. Left. So we got the same function, just shifted left. Okay, the domain, all real numbers, 0 to infinity. Right, from the horizontal asymptote up. Okay, we got, this is reflected down, or reflected across the horizontal asymptote, and then it's shifted up 3. So up 3, 1, 2, 3. Here's the horizontal asymptote, and now it's reflected down. So it's going to look something like this. All real numbers. The range is from the horizontal asymptote down. So negative infinity up to the horizontal asymptote, which is 3. Okay. Number 15. So up to, that's the first thing I see. So up to, horizontal asymptote is up to. And then to the right, 1. Right, to the right, this way. 1 unit. So 1/2, 0, 1. So here are our key points. Our key points. All real numbers. And then 2 up to infinity. Can't see it. All real numbers and 2 up to infinity. Okay. It's going to be down 4. 1, 2, 3, 4. And then the normal points, right? So up 1 from the horizontal asymptote. It's equivalent to 0, 1, right? Because if we are at 0, 1, we would just go down 4. 1, 2, 3, 4. And there we are. 1/2. So it's going to look like this. All real numbers. And then from the horizontal asymptote up to infinity. Okay. -5. 1, 2, 3, 4, 5. And right 3. So normally we'd have 0, 1. Right. So we're going to go down 5 and right 3. 3, 4, 5. 1, 2, 3. And then left and down 1/2. And then right up 1, right up 2. Right, do it enough and you'll start to get quicker. Okay, all real numbers. And then horizontal asymptote up to infinity. All right, last one. So plus 6. 1, 2, 3, 4, 5, 6. Y equals 6. It's reflected down and then left 2. So normally 0, 1 would be the spot where it goes, right? But that's not the case. It's reflected downward and it's going to move left 2. So 1, 2. All right, so that's where it is. I'm going to erase so we don't get confused. And then the other 2 key points are going to be to the left 1/2, to the right 1. All right. There it is. That's what it looked like. All right. All row numbers. Can't see it. All row numbers. And this is going to be from the horizontal asymptote down, or from negative infinity up to the horizontal asymptote. Okay. I wouldn't worry about the factoring completely. I wouldn't worry about that. All right. So that's it. Hopefully this helps. Remember, if you want more content, go ahead and smash the like button. See you guys next time. Good luck.